Welcome back, everyone. In this video, we're going to be moving into chapter 3, and in this chapter we're going to be examining non-algebraic functions. And what I mean by that is we have 3 functions that are not considered algebraic. We have exponential, logistic, and logarithmic. And these have a wide range of applications. But in this video, we're focusing solely on exponential functions. And we've seen this before, a while back in Algebra 1, in Algebra 2 again. You expanded your understanding, you looked at it more. But let's just compare 2 functions that we are familiar with. So f of x equals x squared, and then the function f of x equals 2 to the power of x. Now with each of these, both of these functions are written in this form: a base raised to some exponent, and we're saying that they are equaling some numeric value, so some number. And the difference with these two is that what we were just coming from, we had a variable as our base. So we had x cubed, x to the power of 4, 5x squared. Everything had a variable as the base and some constant as the exponent. Okay? So when we string pieces like this together, we call it a polynomial. But when it's just a single term, x squared, x to the power of 5, 5x cubed, we call these power functions. And that's not the focus of this chapter, but we're comparing it to a function like this, where our base is a number, or a constant. And then our exponent is where we find the variable. So when this occurs, when our base is a numeric value and raised to a variable, we call these exponential functions. And that is how we're going to determine if a function is considered exponential, is we examine the base, we examine the exponent, and do we have this combination. So the basic form of an exponential function, most often we see it as this: some value a multiplied by some value b raised to the power of x. And when we look at this, when we try to understand this form, a we would consider to be the initial value, which, in other words, it's the y-intercept when examining the graph. So we have this, and then the b for exponential functions, b will often be greater than 1. There is a circumstance where it's less than 1, but we'll examine that at another time. But something to note about these functions, exponential functions, is that they're continuous on all x values. So that its domain is negative infinity to positive infinity. That's for all exponential functions. Okay, so let's take our definition of an exponential function and look at various problems and see if we can determine yes or no, is it an exponential function? Okay, so let's say we have f of x equals 3 to the power of x. So we're asking, does it have a constant as a base? Does it have a variable as an exponent? Yes, 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 this is an exponential function. Let's look at another. So g of x equals 3x to the power of 5. So we're asking, do we have a constant as the base and a variable as the exponent? No. So constant, base, variable, exponent. No. Therefore, it's not an exponential function. This is an example of a power function, actually. And let's look at another. So we have h of x equals -2 multiplied by 3/2 raised to the power of x. Okay, so something a little more complex than our first example. Let's check. Do we have a constant base? We do. Do we have a variable exponent? We do. So with those two occurring, we would say, yes, this is exponential. Okay? But what about this function? 3 multiplied by 2 raised to the power of -x. Okay, so thinking of this, would we classify this as exponential? We have a constant base. Yes, we have a variable exponent, but we have this negative in front, and does that change anything? So what we've seen before with exponents is a negative exponent truly results in us looking at the reciprocal. So it would be 1/2 to the power of x. That's the effect of the negative on the exponent. So now we examine it again. Constant base, yes. Variable exponent, yes. Therefore, we have an exponential function. Okay? So let's move to another kind of focus, another topic in this. That would just be, evaluating exponential functions. And what I mean by that is, let's take the function f of x equals 2 multiplied by 3 to the power of x, and we're examining what is the value of our function when x is 4. That's what it means by evaluating. So we place 4 in to our function, and we achieve 2 multiplied by 3 to the power of 4. Yes, we could put this into the calculator and get a quick answer, but understanding what this is telling us is we have 2, our initial value, multiplied by 3 4 times. And we end up with a result of 162. So 3 times 3 times 3 times 3 is 9 times 9, which is 81. 81 times 2 is 162. Let's try this again. So let's say we have f of 0. Okay. So 2 times 3 to the power of 0. 3 to the power of anything to the power of 0 we know to be 1. And we get 2 times 1, which is just 2. And that should make sense because x of 0, this is going to give us the y-intercept, and we knew from the beginning that that was our initial value. So that should make sense that we got 2 as a result. Let's look at another. So f of -3. Okay, 2 times 3, -3rd. Negative exponents, as we saw before, negative exponents have the effect of flipping our sign, so flipping our value. So we have 2 multiplied by 1/3 to the power of 3. 3 to the power of 3 is 27, so 2 times 1/27 is 2/27. All right, so there is another part to this video, but before you begin the next part of the video, I would like for you to evaluate this function when when x is 1/2, and evaluate this function when when our x value is 1. Any questions, comments, post them in the classroom, but this is just a basic video. How do we determine if something's exponential? And then with that exponential function, how do we evaluate it with different x values? So going from here, the next video, we're going to be looking more into how exponential functions appear in tables and in graphs.